Hello and welcome everyone to Moyes. I'm your teacher Gulfam and today we will be dealing with number systems. You might have heard about numbers. Actually, you have seen what numbers are. So basically, if I ask you, tell me what is numbers or tell me what are numbers or how can you define numbers? You might say 1, 2, 3, 4. These are dot 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 dot. These are numbers. And it goes on. So you have 5, 6, 7, 8 and it just goes on. But then you also have numbers -1, -2, -3, -4, -5 and it goes on. Now these numbers can be represented in a number line. You might have heard about it in your early classes. So what a number line is, it is basically a line that goes on in both directions and you have your numbers. You have 1, 2, 3, 4, over here 0, -1, -2, -3. These are positive, whereas these are negative. But 0 is neither positive nor negative. 0 is neither positive, it's non-negative, it's neutral. 0 has a very specific characteristic, but we are not dealing with that right now. So, in a number line, we have positive numbers, we have negative numbers, we have 0. But, if you consider this place, from 1 to 2, or from between 0 to 1, there are still numbers like 0.1, 0.12, 0.123. So you have many smaller numbers in between 0 and 1 and then in between 1 and 2. Now how many are these numbers? Well, basically from 0, what is the highest number you can say? You will say, sir, number never ends. From 0 if you start 1, 2, 3, 4, 5, 6, 7, 8 and it will go on, it will never stop. Can you say me the highest number that is there? Can you tell me the highest number? There is no highest number. Obviously there is some Googleplex and all numbers, but tell me which is the finite highest number? It's not possible. So therefore you have numbers, we call these numbers, they are never ending or they continue till infinity. Just like that, from 0 to 1, there are again infinite amounts of numbers. From 1 to 2, again infinite amount of numbers. What is infinite amount of numbers? Well, from 0 to 1, can you tell me what are the numbers? Well, where do you start? 0.1, 0.01, 0.001. You don't even know how to start from 0 to 1. You know 0, but after 0, what comes? Well, it is confusing, but now you know that we have positive numbers, we have negative numbers, we have 0, and then in between also we have some decimal numbers. And here we have the collection of numbers and their specific names. So you might have heard about natural numbers, whole numbers, integers. Okay, they're very common. So what are natural numbers? Natural numbers denoted by capital letter N starts from 1 and it continues till infinity. So 1, 2, 3, 4, 5 and it continues till infinity. Then we have whole numbers. Whole numbers is a bit different. It is natural numbers. So part of it is natural numbers, but it includes 0, which is an extra number. So 0 when included to natural numbers becomes whole numbers. Then we have integers denoted by capital letter I. What are integers? So all of the whole numbers along with the negative numbers is called integers. So I stands for integers and all the whole numbers and negative numbers are called integers. Or you can also say all the natural numbers and the negative numbers along with 0 is integers, are integers. Now we have rational numbers denoted by the letter Q. So what is a rational number? Any number in the form P by Q where P and Q are integers and Q is not equals to 0. What does this mean? Any number, okay, any number in the form P by Q. So there should be two numbers, one is P and one is Q, where P and Q are integers. So P and Q both belongs to the integer set. So it comes from integers. It could be P could be 1, P could be minus 1, Q could be 1, Q could be minus 1. Are integers and Q is not equals to 0. So this Q, the denominator of this fraction should not be 0. Why? If you can answer this, why Q should not be 0, then please comment down in the comment section below. That's very important question and it generally comes. A teacher will ask you why Q is not equals to 0. So, done? Okay, now I'm answering. Why Q is not equals to 0? Suppose if I have 2 by 0. What does this mean? What does this 2 by 0 means? 2 by 0 means that 0 is multiplied with some number and that gives me 2. Is it possible? 0 multiplied by any number gives me what? 0. How can 0 multiplied with some number give me 2? So that is why, this is the reason why this is said when denominator is 0, it is an undefined number. So whenever you get a sum, you might not get a sum like that, but if you get a sum where the denominator is 0, you will say that that number is undefined. Undefined. It's undefined. Now, leave that aside. Focus on here. So, rational numbers denoted by capital Q. Examples of rational numbers are 1 by 2, 3 by 4, 22 by 7, which is pi. The value of pi is 22 by 7, which is 3.14, and goes on. 7 by 8, 12 by 1. Now, this is very interesting. You might get a question like this. Suppose you get a question 17. Now, you're told, is this a rational number? What will be your answer? Comment down below. Is this a rational number? Is 17 a rational number? Comment down below. The answer is yes. 17 is a rational number. Why? 17 by 1. Don't you think 17 by y, P by Q? P belongs to integer set. 1, it also belongs to integer set. So P by Q, Q is not equals to 0. This is a rational number. So yes, 17 is a rational number. Do not get confused. 17 is a rational number. Also, it can be said it is a natural number. It can also be said whole number. Okay. So now, focus here. Irrational numbers. What are irrational numbers? A number that cannot be represented in the form P by Q, where P and Q are integers and Q is not equal to 0. The same definition. A number, the same definition, only that it can be represented. The irrational numbers, it cannot be represented. So you can say it is a reciprocal of, not a reciprocal, it is the opposite of rational numbers. So these irrational numbers cannot be represented in the form P by Q, where P and Q are integers. You see this star mark? The same over here. So I'm copying it over here. So P and Q are integers and Q is not equal to 0. So irrational numbers are numbers that cannot be represented in the form P by Q, where P and Q are integers and Q is not equal to 0. Keep in mind, you can also say, rather than telling P by Q, you can also say A by B or C by D. It doesn't matter. So what are the examples of irrational numbers? The examples of irrational numbers are root over 2 or root over 3. So root over 2 is 1.414. Root over 3 is 1.732. If you cannot understand it, I'm writing it again. So root over 3 is 1.732. The problem with these numbers, root over 2 and root over 3, is they cannot be represented in the form P by Q. They cannot be represented. It's not possible. You cannot represent root 2, that is 1.414, in the form P by Q. There is no number, there is no fraction in the whole number line which gives this number. Obviously, although this number is present in the number line. You will get this 1.414 in the number line, 1.732 in the number line, but it cannot be represented in the form P by Q. I guess that's clear. Now, we also have another set of numbers real numbers. Real numbers. What are real numbers? Real numbers are all of the numbers in the number line. So it's a collection of natural numbers, whole numbers, integers, negative numbers, your rational numbers or irrational numbers. It is a collection of all of the numbers, that is called real numbers. So all of the numbers in the number line are called real numbers. So I guess you are clear now. You can write it down, note down everything that is there present in the board. Note it down, it's very important. You can pause the video, note down, and then watch the video again. Okay, so in this video, our main focus is on rational numbers. Okay, what are rational numbers? I said it earlier, any number in the form p by q, where p and q are integers and q is not equals to 0, are rational numbers. What are the examples of rational numbers? 1 by 2, 2 by 7, 22 by 7, and you can name any fraction. Now, there is basically one type of sum in your book that is given, and for example, that sum is you have been asked to find 5 rational numbers between 2 and 3. So this is the question. You have been asked to find 5 rational numbers between 2 and 3. Okay, so what are those 5 rational numbers? So those 5 rational numbers can be found out. First of all, pay attention. What you have to do is take 2 and then 3, the first number and the second number, and then divide it by 2. You will get the middle number. So 2 plus 3 is 5 by 2, which is 2.5. So 2.5 is the middle number between 2 and 3. But pay attention to the question. What I have been asked? I have been asked to find a rational number. So 2.5 is not represented in the rational form. So I can leave my number in the form 5 by 2. This is a rational number. Now, I got the first rational number. Rational number 1. Rational number. I got the first rational number between 2 and 3. This is the middle number. Now, can I find more? This is the first one. How to find the second one? See, 5 by 2. Take 5 by 2. You take either 2 or either 3. It doesn't matter. For convenience, I will take 2. 5 by 2 plus 2 by 2. There's no problem. You can do like this. So, 5 by 2 plus 2. Take out the LCM. 5 by 2 plus 2. What will it give me? 5 plus 4 by 2. Then by 2. To simplify this one, I can write 5 plus 4 by 2 into 2. This 2 and this 2 will get multiplied. There's a rule. Suppose A by B by C by D. A is multiplied with D and B is multiplied with C. Keep that rule in mind. So 2 by 2. 2 is multiplied with 2. So 5 by 4, that is 5 plus 4 by 4, which will give me 5 plus 4 by 2 into 2, which will eventually give me 9 by 4. So this is the second rational number between 2 and 3. It is between 2 and 3. Now, the third rational number in the same process. 5 by 2 plus, this time I am taking 3. 3 by 2. What will it give me? 5 plus 3, if I find the LCM, 3 into 2, 3 will be multiplied with 2. What will it give me? 3 into 2, 5 plus 6. What is the LCM? 2 by 2. 2 is multiplied with 2. So 5 plus 6 by 2 into 2. To simplify the question, 5 plus 6 will give me 11 by 4. I got the third rational number. In this way, you can find 2 more rational numbers. The fourth one. How to find that one? Take 9 by 4. Take 9 by 4 and 5 by 2. So 5 by 2, Suppose this is 2 and this is 3. Oh, now the Nile is not straight. Where is the duster? Suppose this is my point 2. This is the middle point, 5 by 2. Now 9 by 4 is this point, the middle point between 2 and 5 by 2, that is 9 by 4. Now applying the same method, I can also find the middle point between 9 by 4 and 5 by 2 for here. I can. So take this number 9 by 4 and take 5 by 2. 9 by 4 plus 5 by 2 whole by 2. Very simple. Take out the LCM. The LCM will be 9 plus, the LCM will be 4. 5 into 4 is, sorry, the LCM will be 4. 2 into what number will give me 4? 2 into 2 is 4. 2 into 2 is 4. So 5 into 2 will give me 10. 4 by 2. If you cannot understand how I am doing this LCM, comment down below. I'll explain there. So 9 plus 10 by 4 by 2. To simplify this, 9 plus 10 by 4 into 2. What? Because 4 will be multiplied with 2. To simplify the sum, 9 plus 10 will give me 19 and 4 into 2 will give me 8. So I got the third or fourth. I got the fourth rational number. And the fifth one also you can find using the same method. I hope this rational number method is clear. Now let's move on to exercise 1.1. Okay, so now we are moving to exercise 1.1. But before I solve the sums, let me tell you one thing. You can skip this part. This part is not important. You do not need to look at what I'm doing and then you will be doing that same thing. If you have watched the video and you have understood the concept really clearly, then move on to the exercise, finish the exercise and then watch this video. Then continue watching this video, or else you can skip this part and move to the conclusion part of the video. Because see, math is all about practice. If you are watching it and practicing, that is called copying and practicing. Copying and practicing won't help you in maths. And also one thing to keep in mind, if you can solve each and every sum in maths, then math will eventually become boring. Math is interesting because in maths sometimes you cannot solve sums, and that is why math is interesting. So please pay attention, and if you can solve by your own rather than watching this video. Okay, so now moving forward, if you want you can watch the video, take a 5-minute rest after watching the video and then solve the sums, or else stop the video, finish the sums and then continue watching. Okay, but do watch the full video because in the end I have something for you. Okay, so exercise 1.1. What is the first question? The first question is 0 a rational number? Can you write it in the form p by q, where p and q are integers and q is not equals to 0? Read the questions once, twice, thrice. If you can solve this sum, solve it in the comment section and show me. So is 0 a rational number? What is happening? So is 0 a rational number? Is 0 a rational number? What do you think? The answer is yes, it is a rational number. What is the definition of a rational number? The definition of a rational number is any number that can be represented in the form p by q, where p and q are integers and q is not equals to 0. Suppose if I write 0 by 1, p by q. P and q both are integers. 0 is an integer, 1 is an integer. But q is not equals to 0. It's true, q is not equals to 0. So 0 by 1, what is the value of that? 0. Or you can also write 0 by 4. What will be the answer of that? 0. 4 into 0 gives 0. So 4 is not equals to 0. That means q is not equals to 0. So 0 is a rational number. So I can write 0 So yes, it is a rational number. Now, question number 2. What the question number 2 says? Find 6 rational numbers between 3 and 4. Again, the same method. I'm showing you 2 rational numbers. The rest of 4 rational numbers you will find by your own. So it said find 6 rational numbers. So 6 rational numbers between 3 and 4. How to find it? Very simple. The first one will be 3 plus 4 by 2, which will be 7 by 2. The second will be 7 by 2 plus 3 by 2, which will again give me, finding the LCM, 7 by 2, that will be 7 plus 6 by 2 by 2, which will be 7 plus 6 by 2 into 2. This will give me 7 plus 6 will be 13 by 4. I got the second rational number. With the same method, you can find the third, fourth, fifth, and sixth. Very easy. Do it in your own. Now, question number 3. Find 5 rational numbers. Again, same easy sums. I won't be doing this sum again, wasting my time. Question number 3 is again easy. You can do it on your own. But still, if you have problem, let me show you. You might have problem while solving this one, I guess. 3 by 5 and 4 by 5. No? So, 3 by 5 plus 4 by 5 by 2. I can write. Take 3 by 5 as A, 4 by 5 as B. So, A plus B by 2. It will eventually give me 3 by 5 plus 4 by 5 by 2. That will be, take 5 as LCM. So, 3 plus 4 by 5 by 2. You can write it as 3 plus 4 by 5 into 2 will give me 10. That will be 7 by 10. So this is the first rational number between 3 by 5 and 4 by 5. The second one is easy. 7 by 10 plus 3 by 5. And then continue. The fourth, third, fourth, fifth, everything will be easy. Do keep in mind, do not get confused when it gives 3 by 5 plus 4 by 5. You have to first find the LCM and then move forward to the next step. In the next step, to make it easy, you show it in the multiplication form. 5 into 2 and then 3 plus 4. And why I'm multiplying, there's also reason. Suppose if I have a number 4 by 2 by 2. What does this mean? This means once I'm dividing 4 by 2, which will give me 2. And then by 2, that means again 2 by 2, which will give me 1. So therefore, directly I can write 4 by 2 into 2. I'm multiplying these two numbers, which will give me 4 by 4. The answer is 1. Same. It's same. So therefore, I am multiplying this number. If you had this question, I got it clear. Now, the question number 4. What does question number 4 say? State whether the following statements are true or false. Give reasons for your answer. 1. So what 1 say? Every natural number is a whole number. So it says every natural number is a whole number. So every natural number comes inside of whole number. Is it true or false? The answer is true. Why? Natural number starts from 1, 2, 3, whereas whole number starts from 0, 1, 2. So I said it earlier. Whole number is basically natural numbers along with 0. So it is true. Second, every integer is a whole number. It says every integer is a whole number. Every integer is a, let's not give the equals to sign. Every integer is a whole number. That means -1, -2, 0, 1, 2 belongs to whole number. Is it true? No, it's not true. False. Why? Because an integers contains -1, -2, -3, so on. Whereas whole numbers doesn't have that. Whole numbers does not have -1, -2, -3 integers. So it is false. Third number. Every rational number is a whole number. It says every rational number is a, again I'm making equal to, every rational number is a whole number. Is it true? Every rational number is a whole number. It's false. Why false? Because rational number contains 1 by 2, 2 by 5, 6 by 7, whereas in whole numbers we do not get fractions. Whole numbers do not have fractions. So, we are done with exercise 1.1. Great. Now, if you have completed all of these, then congratulations. But if you haven't, then it's all over here. You can watch everything from here and write it down. But I'll suggest do not copy, please. That will not improve your mathematics, rather it will degrade. So, in the next video, we will be doing irrational numbers. That will be the part 2. And to let you know, all the notes of this chapter will be given in the description box. And also there will be a question paper. If you want, when we complete this chapter, in the last video, I will be providing a question paper for you. So you can solve that question paper by your own and then submit it in your Instagram accounts, Facebook accounts, and tag me. Do not forget to tag me. My social media accounts, that is Instagram, Facebook, Twitter, will be given in the description box. So do not forget to follow me there, because whenever I will provide a question paper, I want you to solve that question paper and give in your Instagram, upload in your Instagram stories or Facebook stories or in your Instagram post or Facebook post and tag me. I will be there. So yeah, that's it, and I will be seeing you in the next video. I guess I'm pretty much done. Stay at home, stay safe, do not go out.